So biology video number 1. We are going to talk about biochemistry, and the reason that we need to do this is because these are the molecules that make up all living systems, and if I'm going to talk about a living system, I need you to know what the molecules that made it up are, so that when I refer to any sort of process that's happening, I can talk about the molecules that are accomplishing the process, and you know what I mean. So for example, for me to talk about photosynthesis, which is our first subject, I need to talk to you about what enzymes are and what they do first, so that you understand what's actually happening when photosynthesis is occurring. So we're doing this as a bit of background because this information applies not only in this unit, but in all of the units that we're going to do. Very specifically, this information applies to digestion, and that's how your textbook has it grouped. That's why it's in chapter 6 in your textbook. So section 6.1 starts on page 206 of your textbook if you're looking for a reference. And that is where the material we'll cover for the next several classes is going to be coming from. Now the first distinction that I'd like to make in terms of chemical molecules and biological systems is the difference between a micro and a macro molecule. Now, I tried to make it visible with the way I typed it, what one of the differences between them is. Does anyone know what the difference between a micro and a macro molecule is? Yes.
I believe a macro molecule is smaller than a micro molecule.
Macro does mean larger and micro does mean smaller. So it does physically have to do with size. And so I think you said exactly the opposite of that, but knowing that it was about size is really the key thing. So micro, small, macro, large, and I'm going to put the word complex there. Some of the molecules that we would deal with in a living system are very simple. There's an atom or two attached together, and there's not much complexity there. So for example, in the micromolecules categories, we would put things like inorganic minerals. So something that would be an example of that would be something like sodium. Sodium is Na. I'm a big fan of making things shorter than they need to, as short as they can be. And so whenever I refer to a chemical substance, I almost exclusively use the symbol rather than the name, because that is what is universally recognized, no matter what language you're speaking. And so even though this isn't chemistry, we still need to use a little bit of chemistry here. If I ever write a symbol and you're not sure what element that represents, I'm happy to write it out for you. So for example, Na is sodium. It's small. There's one thing, it's just sodium. Something that would be a macromolecule then would have to be something that was larger, something that was more complex. And there are a few specific things that fall into this category that we'll discuss. If an inorganic mineral like sodium is an example of something that is small, something that's a macromolecule has to be much, much larger than that. When I say larger, I don't mean larger, for example, like water. Water is H2O. Technically, that's bigger than sodium, but not by very much. It's still a relatively small, relatively simple molecule. It is not huge. It is not complex. And so we wouldn't put it in the macromolecules category. Does anybody know a type of molecule that might fall into a large or a complex molecule category? Copper would actually, I would put copper, if I said any sort of element down here, copper is still just one thing, it's still just one type of atom. You're right that it weighs more than sodium, it has a bigger mass, but it's not any more complex, and that's why I like the word complex. It's still just one thing, just one type of atom. For a macromolecule, we'll be looking something that has a bunch of things in it. Now an ionic compound, I'm going to put the word ionic here. An ionic compound is usually where I would get one of these minerals from. And an ionic compound usually doesn't have very many pieces to the puzzle either. Ionic compounds are always made out of one positively charged piece and one negatively charged piece. So even though you're right, there could be several atoms there, they're actually still relatively simple in the grand scheme of things. I'm going to write a word here, and the word is organic. Now, probably you've heard the word organic before when we're talking about whether or not we use pesticides when we were growing a particular batch of apples, but that's not the sense that I'm using it in here. The true chemistry sense of the word organic asks you, does this substance have carbon? A lot of substances that have carbon in them are macromolecules. Evidently, not all of them. For example, diamonds are made out of carbon, but they're made out of just carbon. I don't think I would call that a macromolecule. Carbon dioxide is made out of carbon, but that's a really small compound. Some things that are made out of carbon that are very large, very complex molecules is what we're looking for here. Do you have an idea? Oxygen doesn't have carbon in it. I would put oxygen in the same category as macromolecules. That was actually the example I just gave of something that wouldn't be a macromolecule from carbon. You know what? I applaud the effort. There's not a lot of people that would put their hand up 4 or 5 times in the first day of class. So answer away. No, microorganisms definitely would have a macromolecule in them, but I could never say an organism is a molecule. An organism would have to be much bigger than a molecule. I'm going to give you an example. My example is a carbohydrate. Now that I gave that example, if you think about what you are supposed to eat in a day, are there perhaps a couple of other categories that might jump into your head of things that are supposed to make up your diet? You need carbs. You also need 2 other things as per the food guide. Yes? Protein would be one of them. Anybody know what the other one is? Yeah. Fats would be another one. Now, those are things that you need to consume. They're not the only macromolecules in existence. A couple of other macromolecules that I would add to the list would be vitamins. A lot of vitamins are actually pretty complex little structures. The other thing that I would add to the list, it's not something that you eat, it's something that your body produces, but it's actually quite necessary. You want to take a guess? Oh, someone's looking in their textbook, figuring things out. Nucleic acids. Those are things that are larger, more complex molecules. And so our goal over the next few classes is going to be to talk about how these things are produced, how they function, specifically in a human system, because that's the one we'll focus on the most. But very, very specifically, and I'm going to highlight it, we're going to talk about proteins. Proteins act as enzymes, and enzymes are really crucial in a lot of biological systems. So even though all of these things will be important, proteins is actually going to take up the most of our time. Now, luckily for you, since biochemistry involves some chemistry, that means we're going to go to the chemistry lab and do some chemistry experiments in this section of biology. So you can expect that we're going to do 2 labs very specifically in this section, plus another thing that's kind of like lab, but it's more like a fun little game we'll play in class. Some common show today. Have a nice afternoon. Does anybody want to ask any questions about what a micro or a macro molecule is? All right. So we're going to talk about a few of these things separately. We'll save protein to the very end because it's the longest, most complex one. So we're just going to talk about a few of the things on this list. And we are going to start by talking about water. So I'm just going to pause here.